Hi, everybody. All right, so today I'm going to do a lesson over just sections, reviewing sections 8.1 to 8.3. Yeah, hope we're all happy and healthy. Okay, I'm going to turn this little thing off. All right. So here's what I'm going to do today. There are everything this week is going to be just a review over sections 8.1 through 8.3. Okay, now we've got to think all the way back. Oh man, it seems like a really long time ago. Think about what we learned from sections 8.1 through 8.3. Remember, section 8.1 was all about what was that about? That was variation functions, right? Variation functions, right? And remember, we had direct, inverse, joint, and combined. That says combined, if you were wondering. Section 8.2, that was about multiplying and dividing these things. Rational functions. And then section 8.3 was addition and subtraction, right? As well as some these things called complex fractions, right? So that's basically your quiz in a nutshell, okay? All right, so here's what we're going to do today. I would like us to go over these problems. I've got them all listed down here. It looks like 10 problems altogether. I'd like you to have a separate piece of paper out and pause when we start the problem, do the problem, and then watch me go over it. And then the same thing, pause for the next problem, try to do it, and then watch me go over it, and then so on and so on. This video might take you longer. It might not be the length because I'd like you to stop and pause and stop and pause and stop and pause. So I'd like you to do that. So it might take you a little bit longer. Like this Monday assignment might take you a little bit longer. The Wednesday assignment, all I'm really going to do is go over the homework assignment that we have for sections 8.1 to 8.3. I wonder if I can just hit the back button. I think it was just there. No, that's not the right one. That's day 2. Yeah. So this is this the right PDF? Is that the right PDF? I think I have to change this PDF. Is that the right PDF? It is the right PDF. Okay, so if you want to, you can have this open too. If you want to print this out, I mean, it's one thing per slide, but whatever. I mean, you can just have it open. I don't really care. So I'm going to be I'll post the video here, and then this page 609, 1 to 11 right here. I'm going to be going over that in the second video. So you won't see a key there for the second video. You'll just, there's a key here for this assignment. I'll just be posting the second video for it, okay? All right, so here's the first problem. Go ahead, pause, and play when ready. Okay, so it says given y varies inversely as x. Now, I don't need to read the rest. All I know is that y is equal to k divided by x. That's inverse variation, right? Where k is our unknown. So it says 0.5 when x is 3. So k over 3. So I multiply over to get k. K looks like it to be 3 times 0.5. You know, let me pull up a good calculator here. Half of 3, I know that. It's 1.5. Whatever, 1.5. So y is equal to 1.5 divided by x. There's our function, right? Okay, now, what does that mean for us here? Well, you will have your calculators. You can use your calculator on the quiz. So all I'm going to do is plug that into my calculator and then recreate the graph. 1.5 over x. And I'm going to zoom 6 this. I'm going to graph it. Okay, it's got this funky shape to it. I'm just going to go to my table to pick out some points. Okay, looks like we've got negative 6 comma 0.25. Negative, give me a good one here, negative 3 comma 0.5. Somewhere in right there, negative 6 comma 0.25. Looks like I've got negative 1 comma 1.5. Negative 1 comma 1.5. Somewhere in there. Yeah. And then it's going to go up here. So it's got here. And then, oh shoot. What the heck? What the heck am I thinking? It goes down. It's here. Mirror. Mirror. Wow, that was a really good graph. Yeah. Okay, so what am I going to be looking for here? I'm just going to be looking for that it's in the right general spot, and that, you know, we talked about it, this idea of having an asymptote here and an asymptote here. You know, same kind of deal with the other types of, like the logarithmic and exponential. Just make sure it doesn't cross the asymptote, and make sure it's in the generally correct spot. Like if I were to actually put it in this quadrant over here and I graphed it up there, I'd go, you know, just make like a big X. Be like, no, that's wrong. Right? So just make sure it's in the generally correct area. Okay. Butchered that one. Hopefully the rest of these go better. All right. Joanna pays for working overtime. Joanna's pay for working overtime, P, varies jointly as the number of hours she works, N, and her hourly pay rate, R. So P is equal to K, N, R. All multiplication because I'm varying jointly, right? The only time you would ever use division is if I was varying inversely. All right, so it says I've got 103.44 is equal to K times 8 hours worked and 8.62, all right? I'm going to go on my calculator. I'm going to take 8 times 8.62, 68.96. So 3.44 is equal to K times, what was that? 68.96. I divide over 103.44 divided by 68.96, 1.5. The K value is 1.5. Now that means my equation turns into P is equal to 1.5 NR. So that's my new equation, right? So if it asks for the equation, that's my equation. Then it says, okay, find N when P is 213.75 and it's 1.5 times N times 9.5. Okay. All right, so we say 1.5 times 9.5 on the other side, 1.5 times 9.5 gives me 14.25. 213.75 is equal to 14.25. Then, and I divide by 14.25 over to the other side. Okay, so 213.75 divided by 14.25 gives me 15. 15 is equal to N, so she worked 15 hours. Okay, all right. Here's our third one. Go ahead and hit pause. Play when ready. All right, the time T required to pick some apples varies directly with the number of bushes of apples to be picked. B, K goes on top. You know, I'm going to space that out a little bit better. Remember, K always goes on top, no matter what we're doing. Okay, B, and inversely is the number of people picking. P. Okay, so that means T is 1.5 and K times 4 over 3. Okay, so I'm going to multiply by 3 over to the other side first. 3 times 1.5. 3 times 1.5 gives me 4.5. 4.5 is equal to K times 4. I divide by 4 over to the other side. Gives me 1.125. Is equal to my K. So that means this equation turns into T is equal to 1.125B over P. Now it says find B when T is 1.8 and P is 5. 1.125B. All right, so I multiply by 5 over to the other side. 1.8 times 5. And then I divide by that 1.125. That gives me 8. B. So 8 bushels. Yeah, 8 bushels. All right. Okay, let's keep it rolling. Again, pause, play when ready. All right. Now, whenever it's multiplication, I want to do that whole thing where I cross simplify, right? Okay, so I'm going to reduce this as much as possible. Factor out the 2 in the top. I get an x plus 7. Factor over the bottom, I get x minus 5, x plus 5. Times, factor out the, looks like a whole 8, right? Get an x plus 5. And then on the bottom, I factor out the entire 6. I get x plus 7. Okay, now what does that mean? That means I can cross out the x plus 7s, the x plus 5s, and then I can make this 2 over 6 turn into 1 over 3, right? So that means I get full 8 over 3 x minus 5. Okay, there's my answer. If it asked me to identify whatever x values would be undefined in this case, I would probably say 5, -5, -7. I'm not sure if it did. I'm not like, I don't know. Can't remember the original problem. All right. Take a look at this one. Go ahead and pause and play when ready. My daughter's really getting into Nature Cat over there. All right. Okay, so keep, change, flip. 4x to the 3rd, y to the 12th, over y to the 5th, x to the 2nd, times 3m to the 3rd, y, over 6y to the 7th, m to the 3rd, x to the 3rd. All right. All right, so I know a lot of you like to just multiply straight across on top and bottom and then cancel out. I like to cancel out beforehand. Like here, I know I'm going to take the x's and cancel out just to be an x to the 1st. I'm going to take the y's here to cancel them out to be a y to the 7th here. I know I'm going to make this 3/6 a 1 over 2, big 2. I know I'm going to make this, ooh, look, y to the 7th and y to the 7th. Ooh, cancel that. That's awesome. M to the 3rd and m to the 3rd, that will completely cancel out. Do I have any more x's? Ooh, x to the 1st, x to the 3rd here. So that means an x to the 2nd down there. And I think that's everything. Okay, I have 4 on top. Oh no, that 4 and the 2 cancel. That cancels to be a 1. This cancels to be a big 2 here. So I get a 2y on top. That's it. And all divided. What? Oh no, x squared. Whew. Thought everything canceled out on the bottom. That would have been that. So, all right. Okay. Again, the other option of doing that would be to multiply all together first. So let's see if I can do this. Can I select you, clone you? What? That was awesome. Okay. So what do I mean by that? That means that I can multiply straight across. No? Okay. Multiply straight across on top to get a 12 m to the 3rd, x to the 3rd, y to the 13th, all divided by a 6. Okay, put m's first. M to the 3rd, x to the 5th, y to the 7th. Right. Oh, y to the 5th. Oops, 12. There. Okay, the 12. And then we can simplify. 12 over 6 is 2 over 1. M to the 3rds cancel, x to the 2nd on bottom, and then y. Okay. You know, honestly, sometimes that's a little bit easier too. Whatever. All right. Try this one. Make sure you check your answer. Check your answer. Okay. So it turns into x minus 3. Nope. X minus 2. Derp. X plus 5 over x minus 2 equals 7. x plus 5 equals 7, so x equals 2, right? But wait, x couldn't equal 2. No solution. Right? So checking your answer is basically saying, okay, is your answer plausible? Is 2 a reasonable answer? No, 2 is not a reasonable answer. That does not make this equal 7. Okay, a couple more problems. Again, go ahead and pause where you need to, and then let's keep going. Okay. Oh, sweet, common denominators. This gets us a 2x squared minus 18 on the bottom. So I get a 3x squared minus nothing. Negative 2 minus negative 8, so negative 2 plus 8, that would be a 6 on top. Negative 4 minus 5, so minus 9. Ooh, look, I can factor out a GCF in the numerator. Right? Just double check that. 3x squared minus nothing. Negative 2 plus a 6. Yeah. So I get a 3. I get an x squared plus 2x minus 3. All divided by a 2x squared minus 9. Okay, so that means on top I get a 3, and then an x minus 3. Nope, x plus 3, x minus 1, all divided by a 2, x minus 3, x plus 3. So that gives me 3, x minus 1, all divided by 2, x minus 3. Okay, what can x not be equal to? Look at the common denominator. X cannot be equal to plus or minus 3. I'll be very, very, very specific when I want, like, because on the quiz, there's actually blanks for when x is not equal to. If it's not there, then if the blank is not there, if you don't see this blank, then you don't have to write it, okay? If you wanted to, you could distribute the 3 and distribute the 2. That would be fine. 3x minus 3 over 2x minus 6, that would have been fine as well. Okay. Ooh, there's multiplication you got going on. This is fun. Okay, so let's just start factoring. Looks like I can pull out a 3 on the top, leaving us an x squared plus 5x minus 6. Looks like we can pull out a 12x squared on the bottom. Wait, that gives me an x minus, oh, sorry, a 3x minus 1. Okay. Pull out a 3x squared. That'll give me a 3x minus, ooh, that's fun. And then on the bottom, that's all divisible by 3. Is that all divisible by 9? Is 108? 108 divisible by 9? Oh, nice. What a 9. Sweet. It's going to be an x squared plus 4x minus 12. All right. So that will give me a 3 on the top with an x plus 3. No, that won't. No. Yes, no, it won't. Oops, it's not 2 and 3. It's an x plus 6, x minus 1. Yeah, watch out for that one. That was a 2 and a 3. Because it's a negative 6. You're going to find factors in negative 6 that to get to positive 5. So it's a negative 1 times 6. Okay. On the bottom, 12x squared, we'll get a 3x minus 1, but that'll go away soon. And then on the top, 3x squared and a 3x minus 1, but that'll go away soon. And then we got a 9, and then factors in negative 12, that had to get to 4. That would be 6 and 2. So x plus 6, x minus 2. Right? Factors in negative 12, but I had to get to positive 4, positive 6, negative 2. Yeah. All right, let's start canceling. Boop, 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 boop. All right. Looks like I've got, cancel this and this. 3/12 is 1/4. And then this and this, that's 1/3. So that gives me all in total x minus 1 over 12, x minus 2, I think. Yeah, up here. Okay. Whoa, the box gets so funky. Okay. All right, 2 more problems to do. Let's do some subtraction. Okay. Well, remember, for the addition and subtraction, you don't need to factor down the numerators, right? So this is a 3x squared minus 1 over, but I do want to factor down denominators. X minus 6, x plus 3. Whoa, yikes, don't do that. Minus 6, x plus 3. That'll get us a negative 18 and a negative 3, yeah. Minus x plus 2 over x minus 6, which makes sense. I've got my LCD here. Remember, I would write out the LCD, because that'll help us with what x cannot be equal to in the end. All factors must be represented. So we got an x minus 6 and an x plus 3 from our first fraction. And then I need an x minus 6 represented. It's already there here. So we're good. Okay, so the only thing that this needs the x plus 3. Somebody just emailed me. I don't know who it was. So on the left side, we get the same thing. Don't need to change this. On the right side, I get, now I'm going to have to FOIL this. First, x squared, outer 3x, inner 2x. Together we make a 5x plus 6, all divided by x minus 6, x plus 3. Again, all I did to get this x squared plus 5x plus 6 was FOIL this. First is x squared, outer is 3x, inner is 2x, and then plus 6. Okay, so that gives me a 3x squared minus x squared is a 2x squared. It looks like a minus 5x. Yes, that's a minus 5x. Nothing minus 5. And then a negative 1 minus 6 minus 7. X minus 6, x plus 3. Okay, does that factor down? Let's see. Negative 14 that I had to get to negative 5. Negative 7 times 2, yeah, it does. So the top becomes 2x squared minus 7x plus 2x minus 7. Factor here, we get an x with a 2x minus 7, and then a 1. Oops, that's a plus 1. Oh, but that doesn't do anything. That's a bummer. 2x minus 7. So this is an x plus 1, and then a 2x minus 7. That turns into a 2x minus 7, x plus 1, it's a 7, folks. All divided by x minus 6, x plus 3. Whoa. Now, what can x not be equal to? This cannot be 0, right? So x cannot be 6, or x cannot be 3. Oop, negative 3. Excuse me, negative 3. Okay, last problem. Ooh, these complex fraction ones. Now, remember that this is x over x plus 2 divided by this whole 2x plus x over 5, right? Okay, so I've got to get a common denominator here. Before I keep change flat, I've got to get a common denominator, so this becomes a multiply top and bottom by 5. This gets a 10x, right? X over 5. Okay, how did I get that? I just, I wanted to make this, I needed to multiply by 5 over 5, right? So 10x over 5. Reduce that would get us back to 2x if we needed it. So this turns into x over x plus 2. I'll keep it as dividing right now. 10x plus 1x is 11x over 5. So now keep change flip. So x over x plus 2 times 5 over 11x. Now the only thing that can happen here is this x gets canceled out with this x to leave us with a 5 over 11x plus 2. If you wanted to say 5 over 11x plus 22, that's fine as well. All right, there's my answers there. Okay, so I hope this gave you some good practice problems to do. Again, the more practice problems you do with these sections, the better. Yeah. All right. So long, folks. See you in my next video.